Hello friends, myself Rajendra Mahajan presenting my video on linear differential equation with constant coefficient. Solve equation is x square d2y by dx square minus 3x dy by dx plus y is equal to sine log of x divided by x. And if we observe the equation carefully, second order derivative term is multiplied by x square, first order derivative term is multiplied by x, and like this means it is a homogeneous type of term. Then we check whether it is with constant coefficient or with variable coefficient. If we see the coefficient of the first term d2y by dx square is x square, second term dy by dx, its coefficient is x. These two coefficients are not a constant coefficient, these are variable coefficient, and therefore equation is LDE with a variable coefficient, and the type is Cauchys. Therefore the given equation is in Cauchys, and after knowing that it is in Cauchys form, we use the standard substitution to convert that Cauchys to linear differential with constant coefficient. That substitution is z is equal to log x and capital D as d by dz. This is the standard substitution to convert any linear differential equation with variable coefficient to linear differential equation with constant coefficient. Then transferring this log to other side, therefore we get x is equal to e raised to z, and we get the value of x dy by dx as capital D operated on y, the value of x square d2y by dx square as d minus 1 into y, and substituting this in given equation. And then what is the next step? Before that, try to watch the video up to end so that all steps are clear to all of you. Watch it up to last step. I am going to explain each and every step in detail, and therefore substituting this in this given equation, that equation becomes d minus 1 minus 3 x dy by dx is dy and plus y. Taking y common from all this, we get right hand side as sine of log x, but log x is z and x is e raised to z, and therefore simplifying it, we get d square minus d minus 3d plus 1 into y is equal to, transferring this to numerator, we get e raised to minus z into sine z, and therefore we get, that is d square minus d minus 3d, we get minus 4d plus 1 into y is equal to e raised to minus z into sine z, and we call this equation 1. This new equation is in variable z and y. Z is dependent variable, y is dependent variable, z is independent variable. Instead of x, we are having a new independent variable z. This new equation is linear differential equation of order 2 with constant coefficient. Why constant coefficient? Because the coefficient of d square is 1, coefficient of d is minus 4, like this. And therefore, first step, we have to convert the given differential equation with variable coefficient to this form, which we are calling as linear differential equation with constant coefficient. And after getting this form, apply the steps. In first step, we try to find out the complementary function part. and in second part we find a pi part. And for CF part, auxiliary equation is, put this polynomial in terms of d to 0, we get d square minus 4d plus 1 is equals to 0. Minus b, a is 1, b is minus 4, c is 1. Therefore minus of minus we get plus 4 plus minus root of b square minus 4 square, that is 16. 4, a 1, c 1, and divided by 2a 2. This is 4 by 2 means 2 plus minus 16 minus 4, that is 12. 12 nothing but root of 4 into 3. Square root of 4 is 2, and therefore we get that root as 2 plus minus 2 to get cancelled, we get only root 3. Therefore 2 roots, 2 real roots and distinct roots. Therefore this becomes a case number 1 for CF. And as we get 2 different roots, we write down the CF as C1 e raised to m1x. Here it is e raised to 2 minus root 3, instead of x variable is here z, plus C2 e raised to m2x e raised to 2 plus root 3 times z, and we call this as equation 2. If the question is asked for 5 marks, for this substitution and all this conversion, first 1 mark, standard substitution and conversion to linear differential equation with constant coefficient, 1 mark. For getting CF, again 1 mark. Then in second part we try to find out the PI, particular integral. For this linear differential equation, particular integral is obtained by inverse operator technique. Therefore 1 upon d square minus 4d plus 1, which we have to operate on e raised to minus z into sin z. There are 6 shortcut methods to find pi. It is in the form of e raised to ax into capital V. Capital V is here sin z. And therefore, for this type of case, the substitution is d is replaced by d plus a. A is here the coefficient of that z in this e raised to minus z, and therefore it becomes d minus 1. Replace d by d minus 1, and while replacing we have to take this before the inverse operator. Therefore e raised to minus z 1 upon, replacing d by d minus 1, we get d minus 1 whole square minus 4 times d minus 1 and plus 1, which we have to operate on capital V. Here that capital V is sin z. Remember this step. Then simplifying it, it is d square minus 2d plus 1 expansion minus 4d plus 4 and plus 1, which we have to operate on sin z. Therefore it is e raised to minus z 1 upon. Simplifying it further, we get d square minus 2d minus 4d minus 6d 5 plus 1 6, which we have to operate on sin z. And as it is operated on sin ax plus b or cos ax plus b type of term, the working rule or the replacement is for d square is replaced by minus a square. Minus a is the coefficient of z. Here that coefficient is 1, 1 square is 1. Therefore replace d square by minus 1. We get e raised to minus z 1 upon minus 1 minus 6d and plus 6 operated on sin z. Rewriting it, it is 6 minus 1, 5 and minus 6d, which we have to operate on sin z. And as it is operated on sin z, we have to replace d square by minus a square. Means there must be a term of d square. Here it is not having that term of d square, only a single term of d. And therefore, to get that term of d square, we rationalize this term, multiplying and dividing by its conjugate. The conjugate is here 5 plus 6d and divided by same term 5 plus 6d. And therefore, it is e raised to minus z as it is. A plus b, a minus b, that product is a square minus b square. A square means 25 minus b square 6d square, it is 36d square, and this operated on sin z. Therefore we get 5 plus 6z operated on sin z. This is the last step, and as it is operated on sin z, once again we have to replace d square by minus a square, nothing but minus 1. Therefore we get pi is equals to e raised to minus z, d square replaced by minus 1. Therefore we get 25 minus 36 into minus 1. 5 times sin z, we get 5 sin z plus 6 z, it is 6d, not z. Therefore, derivative of sin z, 6 times derivative of sin z with respect to z is cos. Therefore, it is cos z. And therefore, we get e raised to minus z, 36 plus 25, we get 61 into 5 sin z plus 6 cos z. If you have this pi correctly, you will get 2 marks. Then complete solution is always obtained by taking a combination of CF and pi. Therefore, complete solution is equals to CF plus pi. Complete solution is always for the dependent variable. Here the dependent variable is y. C1 e raised to 2 minus root 3 times z plus C2 e raised to 2 plus root 3 times z plus this pi. Therefore, it is plus e raised to minus z by 61 5 sin z plus 6 cos z as the required solution. Here the obtained solution is in terms of z and y. Z independent, y dependent. But if you see the original equation is in terms of x and y. Y dependent, x independent. Therefore, the final answer must be in terms of x and y. Therefore, once again we convert this z in terms of x. And therefore, final solution is y is equal to C1 e raised to z is nothing but x. Therefore, it becomes x raised to 2 minus root 3. C2 again e raised to z raised to this means it is x raised to 2 plus root 3. I have converted in terms of x plus e raised to minus z. X is e raised to z. Therefore, this becomes x raised to minus 1 divided by 61. 5 sin z, 5 sin z, z is nothing but log of x, plus 6 cos z, 6 times cos of z, z is again log x. And whatever this last step, That is the required solution or required answer in terms of x and y. For this step you will get 1 mark, total 5 marks. This is the generally the scheme of marking. Therefore remember the steps, remember the scheme of marking also. In my next video I will discuss the point or the second type of this LDE with variable coefficient, that is Legendre's form. Please like my video, share it, as well as subscribe to my channel if you are not subscribed yet. And to receive the notification for my such type of all new videos, please press the bell icon. Thank you. Thanks for watching.